70 to 2020. Okay, the country changed a lot. Okay, so today I happen to know about TRIZ in 2002 when I entered education at master's level. Basically, my students were given a QFD chart in a multinational company, and then in the QFD chart there is something called a contradiction mapped in the roof of the matrix. So they came back to me and said, "Sir, how do we really resolve these contradictions?" And I have to start. So this is the first time almost I came about QFD, and then I have to seek what is QFD, have to learn, and then how to resolve contradiction. It was written in a book. So I sought some help from TVS at that time. TVS was actually using trees. There were a lot of trained people, and then it fascinated me to go further deep into this system. So 2002, and I introduced this as a semester subject when I designed the syllabus for the Coventry University master's program, which was offered in India. So it became a full-fledged semester subject, and it was very successful. So I'm just sharing you, and I believe TRIZ, some of the tools of TRIZ can be brought to the design process, and it will benefit to the professional designers to treat design as an innovation. So today I'm talking only on the technology evolution trends. There is a derivation of the knowledge that is happened, and we could actually predict what will be the future and what will be the product. It's a very powerful tool, in my opinion, and we don't have to probe in the dark to innovate. So the ready-made knowledge is available across the globe, which we can exploit as designers. So that's going to be the theme today. All right. So I'll start presentation. I'll just switch off my. Yeah. So are you able to see my screen?
Yes.
I mean, so basically, I'm okay. Yeah. So I will try to define first innovation as I perceive it, probably the latest understanding or my understanding of design as essential characteristics which qualify it to be called as innovation. It has to be, the new. So the newness is one of the primary important factor to be eligible to be called as new. It has to be in use. That means it has to be implemented successfully. It has to impact society, and it has to generate revenue for the organization. The third characteristic is that it has to, so it will be successful only when it has got a value addition that is recognized by the user. Basically, it creates profit. That means it has to have useful, usable, and desirable characteristics. Am I audible?
Yeah, absolutely.
Yeah, so okay. Yeah. So basically, if I have a new idea and it is got a value proposition, but it is not implemented, it is then only a creative concept. So because one of the element is missing. If I have a value addition and implemented, but it is not new, what can this be? It's only an improvement. If it is new and it is implemented successfully, but it does not have a value composition, contribution, then it is a novelty or a variety. I think this is a very distinctive characteristics which I, want you to remember, whether you are doing improvement or novelty or a variety or innovation. Okay. So basically, innovation has to have these three fundamental characteristics. It should be called as innovation, and that is what the demand of tomorrow is going to be. Right. So what is the new factor, which probably is very, interesting to us, and then where do we get this new factor from? Okay. So you can't do things the way they have always been done and claim to be innovative. To innovate, you have to generate and use ideas that are new and different from what has been tried before in this context. So watch the word in this context. That means that we are doing in a particular context. New does not mean no one has ever done it before. If it has not been done in this context before, then it qualifies as new. So clarity on what is the newness of the system or problem that we are doing. The idea of newness is context dependent. So where do we get the new knowledge? We can't solve problems by using the same kind of thinking we used when we created them. I do hope you recognize who states this. Doing the same thing over and over again and expecting different result is insanity. You can never solve a problem on the level on which it was created. This is a fundamental, I think all of us as designers have to understand, because the solution is created, sometime back where the entire situation is different, the context is different. So I cannot use the same approach to solve this problem. I have to have a different approach, different knowledge, different skills, different thinking. Context has changed. The change is not predictable for tomorrow's future. It requires a new way of thinking. You need to bring in new knowledge, and which is the really hallmark of innovation. According to me, innovation in the 21st century is converting knowledge into wealth. So how and where do we look for new knowledge is a question. Make it a practice to keep on the lookout for novel and interesting ideas that others have used successfully. Your idea has to be original only in its adaptation to the problem you are working on. Thomas Edison made a statement, who is far, junior to, the TRIZ, that topic that I'm talking, the creation of, Achutha. He created this knowledge only in 1956 onwards. So I do not know how this, we can pick up knowledge across the globe. How did Thomas Edison conceptualize? But, he was probably laid the foundation of using the knowledge available across the globe. Anyone can look for fashion in a boutique or history in a museum. The creative explorer looks for history in a hardware store and fashion in a airport. Again, where to look for knowledge. Okay, they're very important statements. Searching for new idea is like looking for a needle in a haystack. Thomas Edison called it genius is 1% inspiration and 99% perspiration. Because, it was, we call as, TRIZ people, that is creativity in the dark, going around, conducting experiments. So I do not know how many of you know that Thomas Edison made more than 1,000 experiments to create the bulb. He made about more than 6,000 experiments to create the, the battery. So can we afford to do that, trial and error method? That's a question. So today we can't afford to do that innovation like that. So we need to have a set procedure or a systematic way of, doing innovation. That's why this TRIZ is known as systematic innovation. So the philosophy or the hallmark of, the theory of this TRIZ is somebody, someplace has already solved this problem or one very similar to it. Creativity is now finding out that solution and adapting it to this particular problem. So this is the whole way of, implementing innovation. That means, somebody in some place, some domain. I'm not bothered about which domain he is doing, that, mechanical or electronics or chemical or whatever it is, has already addressed a problem. This is the, just derived after analyzing more than 2 lakh pages.
So, Achutha ji, just one second.
Yeah, tell me.
Are you advancing the slides or you are on the same slide? We just want to cross check.
You're not able to see my slides at all?
We are just seeing the second slide.
How come? Is a lag time or what?
No, they actually the slides have not moved. If you're presenting, maybe they're going into another monitor or something else.
No, same monitor. Have you seen? Okay. Good.
So the video is frozen. So maybe you need to switch it off and switch it on again.
No, but we can see Achutha ji properly.
Huh?
No. Video as in the monitor input.
You will need to stop screen share and again do screen share.
Yeah, okay.
All right, okay, I'll do that. But I was assuming that, you're able to see the screen moving forward. Okay.
No, thanks to Hari to, for pointing that out.
Yeah. So sometimes presenting the desktop will not freeze it. Okay.
Yeah, my slides are on the desktop only. So now let me see whether you're able to see that.
If you can just present it.
The new factor, innovation new factor, I'll move the slides.
Yeah, we see the
Are you able to
slide.
see now?
Yeah, the new factor we can see.
You're able to see the slide?
We can.
Huh?
Can you please put it on slideshow mode if you don't mind?
It is actually full this thing and slideshow. I think it is in the slideshow, right? Yeah, I'll just call a minute, I'll call my son.
Yeah.
No problem, sir. You can proceed. Yeah.
Sometimes presenting the PowerPoint itself as a window is Sir, it's easier if you just present the desktop instead of presenting the PowerPoint.
Okay.
It will not get so many times frozen, is what my experience is.
Now is that
Yeah,
okay?
Yeah.
This is okay. If you can just change the slide, let's see if it moves.
Yeah,
This is
moving.
fine. Yeah, this is okay.
Yeah.
This is fine.
Yeah, I will not go back to the slides. I think there was nothing.
That's fine. Yeah,
much, so
yeah,
I
yeah.
will, I'll come to the, yeah. So this was the theme. I said somebody someplace already solved this problem, right?
Yeah.
And so that means knowledge is available to me across, is free. So basically, Altshuler is Altshuler is a Russian, and he is a patent analyzer. And probably, it's very interesting to read his bio. He had a patent at the age of 15 or something like that. So he was even jailed in the Siberia. So he studied more than 2 lakh patents, probably all belonging to the manufacturing industry during those days, right? In the 60s, 70s, there was no IT and all. So all patents were from manufacturing sector. So basically, he says communicating from an engineer to an engineer. I mean, this is what, he said. And he observed that people are repeatedly solving across the globe from different domains the same problem and applying for patent and receiving patent. So he found a pattern of how the inventive solutions or innovation solutions are developed. So he codified all these learnings from these things. So later on, he's no more. Actually, this knowledge was not actually even available to the outside the world. Only when Russia broke, that Perestroika movement happened. And so Gorbachev, you don't know that, when he was the president, this Perestroika, that was an innovation movement in political system happened. And so this, Altshuler and his team, they actually migrated. They came out from Russia and then they started sharing the knowledge. Then it was in Russian language, then it was translated to English. And so it is now becoming, domain of Americans in the Western world. So there are different versions of TRIZ. So probably, I'm associated with a company where, I learned the TRIZ from where Altshuler was directly employed, or, his knowledge was taken. That is known as CREAX, software, if you know, CREAX. And so this whole CREAX software is written in India. Actually, that is, and complete knowledge of TRIZ was available through a software. And so I'm trained by these people. So I underwent a special training, advanced training on TRIZ from this company. And so that's how, I started, becoming good in this or, using this. So basically it's a very wonderful knowledge. And then more than now 10 lakh patents have been analyzed subsequently by others, including the patents of IT and other fields. And they have validated that this is available even today. So that is where, it's becoming very, most of the courses abroad, including product design, is making, TRIZ as a subject, including management schools. So it has now been adopted to the management schools. It's been adopted to the IT field. There are different versions. So what I give you is known as classic TRIZ, propagated by Altshuler. So it actually involved about man hours, 1,500 man years of research, and they are distilled from all engineering patents, and it is applicable today. And so it has got actually all the tools required for what we call design or innovation process. That means discovery of the real problem. We have tools. Then we can actually develop different levels of innovation solutions. So we can choose what type of solution I must give you. So that is, again, we have the different tools. Then we can actually generate concepts, validate the concepts. So we have a set of tools for the entire process of innovation in this. I'm not going to cover all of them. Only one, a tool called Technology Evolution TRIZ, which enable us to strategize innovation. That's the only one which we'll discuss today. Okay. So basically, these are the findings, the gist of findings of patent analysis. Problems and solutions are repeated across industries and sciences. That means, similar problems with like reinventing the wheel has been happening across the globe without aware of being what are the previous solution already available for me to adopt. Classification of the contradiction. So there is something called contradiction, which actually we were never, recognizing it. We are always using the word called optimization. Okay, every design actually results in a contradiction whenever you do it. But we find some in between solution, right? We say compromise solution or optimization. There's a very decorated, approach that we do. We have a lot of algorithms to optimize a solution. For example, if I say I want to increase the mileage of a car, what normally I will do increase the mileage of a car? Probably I will reduce the weight of the car. Am I right? So when I improve a parameter on which is desired by the customer, the solution actually affects other parameters adversely, and that is known as contradiction that we call. And so what we do is optimize, improve to a certain extent. When I actually reduce the weight, actually what I'm doing, I actually reducing the impact resistance, crash resistance I'm going to resist. So normally all design compromises have, these deficiencies. So what TRIZ, Achutha says is never compromise, innovate the solution, eliminate the contradictions. So patterns of technical evolutions are repeated. Again, he says, there is an evolution which is repeated in different domains. You can predict, what will be the next level of innovation. It is possible to do that. So this is about the most important, benefit we have. Creative innovations use scientific effects outside the field where they were developed. There are a lot of scientific effects, geometrical effects, physical effects, chemical effects, which actually have been developed for a particular domain. What he says is that I can use it in any domain. So this again, so all this knowledge, gentlemen, are codified. Okay. So they are available easily for us to search and use. Okay. That part I'm not going to deal today. But otherwise, it's very easy, like income tax ready reckoners. How do we use now? If my income is so much, what will be the tax paid? To that extent, they have made it very codified and easily adopted. Okay, so this is the thing. So these findings are, like Achutha, while researching 2,000 lakh patents, found that patents encompassed a very broad range from very ordinary to extremely inventive solutions. So then he actually classifies these inventions to 5 different levels. So this is the first, learning that he says. You can have innovation of different levels. That means you can create innovative barriers, competitive barriers for, your competitor not to enter the field. So more difficult the innovation you do, it will be, difficult for him to break. So you can observe that the level of invention achieved, he called as invention because during those word innovation was not common. So a lot of people use inventions. It has got a strong relation to the knowledge use, very, very fundamental. The solution you develop depends upon what kind of knowledge you use. Okay. So basically, level 1, he calls, there is a simple improvement of a technical system requires knowledge available within the trade only, relevant to the system. Suppose if I am designing something, a spanner, okay, mechanical, I am from a mechanical domain, right? I have enough knowledge within my trade, that's mechanical engineering, I can solve the problem. So there is a first level of almost obvious improvement you are doing it, okay? That's one level of innovation. Level 2, still the solution may be patentable, okay? Don't confuse patentability and innovation, okay? Level 2 is actually an invention that includes a resolution of a technical contradiction. Technical contradiction means, when I do improve one technical parameter, and it adversely affects more than one technical parameters on the other side. So that is a technical contradiction. There are 2 types of contradictions. Okay, briefly. I told you when I want to improve a mileage of a car, I reduce the weight of the car, so it affects the impact resistance. Okay, so that's a technical parameter. So I may not have a knowledge with me, but I can use the knowledge of the automobile industry as such. So that is a level 2. That means I go beyond. Maybe I will see how Ferrari is doing, or how Toyota is doing, or how Tesla is doing, something like that. So that is I still look for a knowledge within my industry domain. So that is a second level of innovation that's possible. The third level is where we are doing invention containing a resolution of physical contradiction. So physical contradiction is tougher to resolve. So you require knowledge from other industries or other domains. So you cannot resolve the knowledge within the domain industry. So this is first learning. What is meaning by physical contradiction? That means I'm dealing only with one parameter of a equipment or a material or a component. For example, if I take a suitcase in our house, right? A suitcase, the volume must be maximum when I'm using the suitcase when I want to travel, right? But suitcase volume must be minimum when I want to store the suitcase in my house. It should not occupy more space. That means that, it is known as, that is, I'm dealing with only one parameter. It has to be large, it has to be small. Okay, so this is a very, very interesting parameter actually. If you really, I will give you another example. If I have a hole in the heart, earlier we used to have open heart surgery, right? Why? Because the valve or the sealant was not able to change the shape of the volume of the stent, what you know as stent. Today, I don't require a open heart surgery. The stent is having actually the narrowest cylindrical form. Okay, so I can insert through a catheter and reach there. Moment it reaches the heart, the temperature wise, it has got a memory built into that. So we call as memory shaping, shape memory alloys. It actually takes the shape of a plant and seals the hole. So that means, you see, I'm looking at the one parameter. That is the shape of the object at one time or a place, and the shape of the object at another time and a place. Okay, so this is very interesting. Briefly, I hope these examples will make you to realize what I'm talking about. So, to resolve a physical contradiction, I need knowledge from different domains or different sciences. So this is the third level of innovation. If you achieve a third level of innovation in your system, baking that, or it creates a much more serious barrier for your competitor to copy for it. Okay, this is the advantage. So level 4, I don't bother about the current system, and so I want to develop entirely new system which does not have any of these contradictions in the new system. So I'm not improving any existing system. So this requires actually a different set of knowledge altogether. Level 4, a new technology is applied which contains a resolution of contradictions with better approach to what we call as ideal result. So he created another, concept called ideal final result. That means think of an ideality solution. We'll briefly deal with this, okay? This new technology includes a breakthrough solution that requires knowledge from different field of science altogether. Okay, so this is so knowledge and level of innovation has got a direct relations, which you must recognize. Level 5 is completely, discovery, the world, the entire new science being done. So basically laser is a level 5 invention. Discovery of a new phenomena or a substances like shape memory alloys are new phenomena. They are level 5 discoveries first. Then using that, I have a product in the level 1, level 2, level 3, level 4, etc. This new knowledge provides for the development of new technologies with utilization of the new phenomena, resolving existing contradictions with better approach to reach ideality. Okay, we are approaching an ideal solution. Okay, so level 1, let me try to give you some example of, I want to create a mouse trap. Level 1, level 2. Basically, we started conventional, right? Somebody changes the material, makes a, steel wire bob. Somebody, basically tripping, simple fundamental principle are same, am I right? Okay, let me point the options. Yeah, I hope you will see this, right? So you have a same, spring and then, trip the spring and put the bait. So you could be, they are all playing around with level 1 and level 2, in terms of certain parameters. So now this is again a level 2 solution. It is a bucket. And you keep, there is no spring there here. Actually, the bait is applied here at the bottom, maybe peanut butter or something like that, and then and close it. So they are these are sold very frequently abroad. Okay, so the rat because of the smell attractiveness it climbs and then it actually moves. So moment it goes further down, actually it gets trapped and it's going to fall down. So now level 3, now I am not using any tripping mechanisms, springs, etc. So I am looking for a resolution of a physical contradiction. That means I use a tape, adhesive tape, which I hope they are already sold. These are sold. Most of you might be familiar. So level 3. Now what could be a level 4 solution for a mouse trap? So create a new unique combination of function. So I'm not dealing with the present principle of the concept function. I want to find a new principle altogether. They've never been used before for catching and relatively small moving objects. So I look for a knowledge in a very different way. Okay. Level 4 strongly depends on the discoveries of level 5 and requires knowledge of various sciences. So I need to go beyond the conventional mechanical systems. Can we generate an exotic electromagnetic wave that will stun the mice within a certain distance from its source? So I look for knowledge that we call as field, okay, FIELD. That means he's dealing, all, magnetic fields or chemical field or sonic field or ultrasonic field, etc., etc. So the future depends upon more and more use of the field. Okay. Digital world actually is, exploits a field to a very great extent. So discovery of a new type of electromagnetic waves with the characteristics that later could be used to stun the small animals will happen at level 5, and that I will use and create a level 4 innovation. Okay. So now cleaning the teeth, because recently I saw a lot of people are arguing about the brush, the brush on the finger and all that thing. I never wanted to respond, so I thought let me show you something. Level 4 innovation in the toothbrush. Okay. So we have an ultrasonic toothbrush. They are sold abroad, but not in India. Even in India, I can buy, but probably replacing the bristles may be difficult. I do not know. It requires toothpaste, level 4. All right, but there's a very special tooth which actually uses ultrasonic, molecules impinging on the plaque and removing it. Now level 5. I mean, this is I love it very much. I would love to have this. Is one of the best toothpaste ever developed in the world. Ionic toothbrush does not require any toothpaste. It uses the phenomena that, attracting and repelling, the positive and negative charges. Basically, the plaque is bonded to the teeth by positive ions. So I create a negative ions, and then the plaque is attracted and removed from the tooth. It's a very, very interesting thing. So actually it has undergone, by every trial and all the, dental fraternity in USA are wondering why this has not become popular, because of the very strong lobby of the toothpaste manufacturers in USA. Okay, so it's very interesting, you can wonder. That means it does not require any toothpaste. You just use water as a conductor of this thing. So I'm using level 4 solution. So this is probably the end of the development happens in this. So I can probably change the way the charge value. I can do that, submit, but this is a level 4 solution. Yeah. I do hope you're getting some idea about it, right? Now, what is the philosophy that somewhere, someplace? So you have a problem. Now you have to abstract, define the problem in the terms as prescribed by the TRIZ. That means we need abstraction. The problem definition has become as this language. Altshuler identified in 70s that we in design deal with about 39 parameters in our design. What is the meaning of parameters? Like, for example, weight of a moving object or weight of a stationary object, energy consumed by a moving object. So this is the universal term he used. So now I want to say, when I improve a problem like that, definition, define your problem in the TRIZ terms. So you require special training for it, but I'm just telling you the approach. Then, I can look for the solution. So the TRIZ, definition. So it has been codified in the TRIZ. This is a problem is of this nature. Then, it tells, based on the result finding of the patents, that you use this approach. This is something like, I do hope most of you are familiar with Scamper, am I right? I want to use, creative solution. One of the approach is Scamper, right? That is, triggers are substitute, combine, eliminate, etc., right? Similarly, this actually gives us 40 more triggering, methods. It says, segment, that means break into this thing, use inverse, okay, use prior action. So again, you need to learn this, but this is how I have. If this is the type of the problem, use first this solution, trigger, or this thing that is known as inventive standard. So then apply that idea to your problem and generate the concept. So this is the approach. You need to know how to generate. Like, when you say somebody is Scamper also, you need to have some idea of how to generate a concept based on the triggers, like, substitute or all these things, which I hope, as concept generation methods would have been studied. So this is the very, very simple approach of already generating level 2 and level 3 approaches. All right. So basically this is based on the knowledge that we have got. That is known as, he has found that there are 40 inventive principles used in generating these 2 lakh patents. And it has not been confirmed that 41st inventive principle has not been identified yet today, even after analyzing 10 lakh patents. So 40, but the number of parameters that we deal in design has been increased to 41. When 41 or 48, something like 48, yes, 48. Because when Altshuler was analyzing the patents, we are not dealing with the sustainability, carbon footprint, environment requirements, etc. So all these new parameters have been added, and so but inventive principles used are still remain 40. So this is where somebody was recommending TRIZ 40. Using these 40 triggers, then we find solutions. They are recommended, which one to be used for which problem. So it's not that you try all the 40 triggers. Then now the scientific F. Another approach that we can do is go for a higher level of innovation is evolution-based predictions. That means you can jump from one technology to another level because you have been actually predicted. This technology can be predicted, we can use. This is what I am telling. How do we strategize innovation? Okay. Yeah. So basically, TRIZ is nothing but an analogy. It's an actually analogous problem, dating. So which I hope most of you do that in our thing. So if you take a woodpecker, okay, it's not biomimicry, just don't get confused into this. So it's actually, biomimicry or metaphor. They might look similar, but they are slightly different. So a woodpecker drums a tree as fast as 22 beats a second, creating, deceleration, right? But it is such an impact, and it's not damaged, right? So that is how, we have derived this function, how does it do and how does it is protected, and that's a difference. It's not the shape. So basically, there's a, spongy bone, and then, the shock absorber, so impact resistance, is so big. So we can have things, even which is, impacted by so much of G, it will not damage. So what is the result? I hope most of you know that the flight recorders have been, developed based on deriving the knowledge of the woodpecker, okay, which is actually, put here, somewhere here in the aircraft, right? Yeah, this is a very interesting thing, right? The Betty, they produced a cartoon, which I hope is a fact. I checked again yesterday. 1997, he said, 2021. I don't know how accurate he was. That, education will be online and most beautiful. So, but interesting thing, we don't know how did he do that. But I mean, we can also do that, but, systematically, and we can prove it. That's what, I'm telling you about technology evolution trends. Okay. I want to know, am I okay? Audible space is okay, gentlemen?
Yeah, all good. So I think we have another 20 minutes.
Huh? Yeah, okay.
So maybe you could talk for another 10 and we can open for questions after that.
Yeah. No, Achutha, it's going on well. Please go ahead.
All right.
Yeah, very nice.
Yeah. So what is this evolution trends? So it's a very interesting learning actually. Maybe, you can extend 5-10 minutes, which I hope, you're not finding. So I want to define these technologies. Again, I always believe in this. That is, technology comes from employing and manipulating science into concepts, process, and device. So researchers develop knowledge, science develop knowledges. From knowledge, we have to translate it into technology, then only it becomes useful to us. Okay. Technology is an outgrowth of science. Knowledge applied to products, processes, etc. So my, concept is abilities for embedding the concept in physical form. I call this as technology. Anything that I use to convert a concept into reality is technology. Okay, so first thing he said is every improvement that we do reaches, towards ideality. That means we are going near ideal solution to it, which is a very brand new concept that he has created and wonderful, actually, approach. What can be an ideal solution for a problem we have? So that is thinking openly without any constraint. It may not be possible for us to achieve it. So what we do is we work backwards. What is preventing us to achieve ideality? How do you overcome that? So this is one of the processes that we have. So ideality is equal to, measurable, benefit divided by cost and harm, which is, I hope, everybody takes as a perceived value. Cost is all input costs. Harm is all undesired outputs. These undesired outputs exist in the design product or a system because the way we have designed this. So we must recognize this. So our aim is should be, this goes towards zero. I mean, that's ideality, right? So basically, ideal system is a unique theoretical construct only of a system which delivers all useful functions without being existing. It helps us to think without any restrictions. It shifts focus on the real need of the customer and not on the system that we want to generate. So basically, laser pointer we have, right? What can be an ideal laser pointer? It should point, but without being existent. Am I right? Now, how many of you use laser pointers? It is not existing, am I right? Why? We have transferred the function of the laser pointer to the super system, which is actually required for my projection. That means a presenter. So that actually added the function, right? So that means, this becomes much more economical to us, more innovative. So I get rid of all the physical, system here. So by adding one extra function in an existing system, which is basically necessary, is one of the approach that we use, ideality. Or the remote of the projector itself, right? We have a button. So this is what ideality we can approach. All right. So can you imagine, air freshener in a room without being there? Like, see, there is a, fresh 2 lamp is there. Actually, this lamp does the, the function of this thing. So no more, extra freshness required to be done. So this is how ideality is there. So we can actually achieve ideality to some level. All right. So I think one more, I do not know how many of you have seen this. See, if I have to, prescribe a glass for a person who is, impaired, we need to go to your optometrist or an eye doctor. He will prescribe give the prescription of the glass. You go to your specs maker and he will grind it. Give this. So how many doctors will be required or optometrists will be? But it's very unimaginable. Okay. Even in Bangalore, we have one optometrist for 20,000 people. Okay, according to the latest this thing. So one of the, so this is a specs actually given under the, lot of schemes across the basically the Africa they are giving. You have a specs actually with the 2 pumps here, and this has got a plastic, transparent, pouch where I can fund the liquid here. I can pump the liquid here, and so it becomes. So you do it yourself. You don't have to go to a doctor. Nothing. You can create your own, eye correcting glass. So he's the physicist who created this. So you just hold it and keep pumping. Moment you see the image sharp, close it, remove the pump, you can use it afterwards. Okay, that's where, ideal. Doing it self-design. So we actually, when one of the approach we do is, look for self-patents. And what are the idea to create an ideal solution. Okay. What can be an ideal solution for a lawn mower? Anybody wants to venture? Robotic? Normally, we'll go in this direction, am I right? I will reduce the power, use natural wind power, solar power, etc., etc. But an actually ideal solution for this, if I'm looking for a level 4, invention, grass that looks and feels great, but only grows 40 mm height. That's an ideal solution. So actually, now let me see whether something like this has happened or not. Okay. How do we pluck coconuts? You have already, you can see somebody, in the Kerala or South Canada, they have made a, motorcycle, which will climb also, right? An ideal, solution is make that tree dwarf. You can pluck yourself. So it is possible to approach ideality. So normally, it will lead into lot of inventions. Okay. So what is the ideal system, ideal machine? So I go beyond the washing machine, right? I told you level 4 means I am not bothered about washing machine. What is the real need of the customer? Clean clothes. Now my question will be how the clothes can clean themselves or remain clean. There are 2 options. Okay. So wool and prints claim the shirt can be worn for 100 days without being washed or ironed. Actually, these kind of shorts, like in Arrow, I think they have launched it in Bangalore, these shirts which need not be, washed. You can wash after 100 uses. All right. So clothes remain clean. Okay. So there are actually, like all, America, this is actually originally developed for military people, trekkers. 6 months they go to the Himalayas. I mean, they all remain clean for 6 months or whatever period of time. So they are all sold now. Okay. So basically, I know actually need a dam to generate power. So, it is Minnesota, they have have a turbine, which actually uses the normal flow of the water and then generates almost, 1.2 megawatts of power. These are all real stories, which is required, enough for 1,000 houses. They don't harm any of the, the sea, living creatures, fishes, etc. So this is like a windmill within the water, water mill, you can see that. They are run at a very slow speed for generating enough power. So this is, going towards ideality. I do hope this thing, okay. So basically, technology evolution forms a S curve, which I hope most of you are familiar with the marketing S curve, right? Revenue versus time. But, we treating this is a very differently, I keep on adding the function divided by cost. I add more functions, right? This current technology or knowledge used available to me will not allow me to go beyond a certain level. Benefits cannot be enhanced. That means, it is in the decline. You must now substitute a new technology. So this is where, I can use the knowledge that, it is enough, you can't use that. Okay. So this is again a very different way of treating technology curves. So like if you see like, steam engine to diesel engine to electrical engine to, magnetic levitation, etc. So I actually, this can be predicted very easily and we can be prepared for this, this. So if I see LED light, incandescent lamp to fluorescent tubes, CFL lamp, LED, OLED, all these are, predictable and we can actually implement innovation in advance. So the another one is non-uniform development of system elements. So again, another new concept which actually is brought into this so that your innovation does not fail is, when we create a system, we actually borrow a lot of things, right? Subsystems. Like for example, your laptop requires a chip, right? It says Intel S4, etc. But the laptop manufacturer does not have any control on the subsystem, right? They might be developed together or independent developed. So systems are created using subsystems which are having a different technology evolution curves. So part of the system. And then they have to interact with systems which are again not controlled by us around the system. So when these three different, systems do not grow in the same level, innovation suffers. It's a very, very interesting thing. So according to the researchers, Apple is the only one who can control both system, subsystem and supersystem. I mean, that's a very classic example they give when he developed the iPad. He could actually entire, the whole system he could control. That's why he could become a leader and monopolize that system. Okay. So which is very not possible for us to do that. So let system, subsystem and supersystem. Okay. So we actually, there is a tool where we can, map all the interaction problems, what happens. So basically, if you really see the system design education which you are talking, right? So the syllabus is decided probably 5 years back. By the time he completes 4 years, BDES, he goes, he's already 9 years old, right? When he joins the industry is already far ahead by 2 years. So he is actually behind by about 11 years. Am I right? So this is the conflict we have. Okay, so it's a very interesting thing. So this again has to be plotted before we do the innovations. Okay, since they actually create more complex, more contradictions and innovations, evolution do not happen. Okay, so I hope giving you a very nice example. So super system changing is very difficult. Am I right? Even the CFL was to be designed so that it can fit into this bulb holder. Now what happened? When the LEDs came, I was told that this is the most inefficient LED system because it has been designed to fit into the super system, which is very difficult to change. And I'm not sure, but a lot of experts say LED being a flat is the most efficient system. But we cannot do that because it can be done only in a new, construction or a new laws have to come across the globe. So what actually happens is, when I develop a new LED, I use a subsystem which is probably 5 years old. And then, by the time I've developed and launched into a super system, if it has changed, I'm in trouble. So this is which is known as a system operator or 9-window or a multi-screen analyzer tool. For those who are interested, I'm just giving you further data. It's a very interesting tool which you can use in the first phase of design, like discover what is the problem, All issues can be mapped and, we can do that, okay? So basically, I just give you highlight here. Why people are hesitating to buy electric car? Anybody can tell me? So we have the, like Mahindra is not developing any battery, and he's using, probably picking up the best battery available, which you think, and he picks up also the best motor that's available. So he's an actually integrator, right? Then he sells a buyer now. What happens? It's actually Reva. The range was less than the length of kilometer that outside a ring road, which is 62 kilometers. If I start from one point, I'll not be reaching back home if I am in a Reva, because I cannot buy kilometers power, right? Like in a power, petrol station, I can go to any petrol station and fill petrol. Now, until super system is not existing, and that's why this innovation suffers. Okay, so there is actually a, like idea developed by an Israeli company. So they give you battery free, and this located in such a way that within 1 minute, you can buy so many kilometers per month, like that. Okay, so until that happens, innovation suffers. I do hope you get some idea about it, right? So increase complexity and system. So again, when we develop, we start first make it work properly, make it improve performance, all these things. Then we say, oh God, it has become unmanageable. It has become too complex. So then we have to say trim the system. So you have to make it more trimming. So this again another finding of the TRIZ development. So most important finding is increased dynamism and controllability. That means the products have to be adaptable, changeable, controllable. It's a very important thing. So that means flexibility of form. That I told you, the stunt have a different form when it's outside, and it takes a different form when it goes inside the heart. And flexibility of the structure, it can change the way it is behaving. Flexibility of operating states. So all these are very important requirement of the future. They say the technology can make this happen. Okay, very powerful. So controllability is another very important thing. Direct action control, like 70s when you have a TV, you have to go to the TV and then change the channel, by pressing the TV where it's located. Am I right? What will be the future of future TV? You don't have to have a remote, possibly, I hope so. I mean, intelligent feedback. It actually maps all our behaviors and automatically change the program at whatever time it comes, right? I don't need a remote. So that is how, again, another, technology trend we can exploit and create the future products. Okay. So transition to the super system, I showed you the laser pointer was transmitted to the remote or a presenter or to the remote of the projection system. So this is one of the trends that has been observed always, because when you shift the technology, you can say contrary to the super system becomes more valuable. Okay. So basically systems merge and it becomes, one merging, so becomes bi and poly systems like that. That's one this thing. So basically, I mean, this thing. So what happens, it is one system, you merge, it becomes bi system, you merge most of them, it becomes poly system. I do hope, we had a record player, then recorder, then you got 3-in-1, 4-in-1, 5-in-1, right? You got a scanner, which can do printer, all those kind of things, right? I mean, I'm just to make fun, I'm showing this, we have a mono system, have two of them bi system, have poly. I mean, I hope, this is how, development takes place. If you see that this is a mono system, two of these sharp edges became bi system, and multiple of them become poly system. That means multiples become one system. Okay, so this becomes new mono system. So this is another very important, trends we can exploit. Yeah, this is only for fun. So if we just say, pencil with the eraser by system, record, erase, copy, and all that things. So by system. Mostly, this is another way of putting, reducing the number of items that we design and manufacture. Macro to 5 level, another micro level. Everything is micro, actually. Probably, he did not have the technology of nano. Probably tomorrow we have to say macro to nano. Okay, so we change at the level of microns or, molecules. Okay, so that's one of the predictions that he has done. So, I mean, and, so it becomes, another thing is the next change that he says when we go to the micro level, we start using more and more fields. Okay, like magnetic fields, induction fields. So electron, that IT has been considered as a electron fields. Okay, so that is, electrons move there, right? So that is how, we are done. I will, skip this. I'll show you some examples. I think you'll be there. One of the important trend is decreased human involvement. That means, man becomes lazy and lazy, more and more lazy, or he does better work. And, his involvement gets reduced. Okay, so, man was doing everything himself, right? He using his muscle power. Then he started developing man plus tools. When, power was generated, he developed powered tools. When, he could control the power, he made semi-automatic tools. Then man has made automated tools. He still uses automated tools. Now there won't be involvement of man. So future generation products will be completely automated. Can anybody give me one example here? It should flash across your mind. What is a drone? Drone is an automated tool, right? You have moved from here to here. Okay. So basically, gentlemen, I'm just coming to the last few slides. So there are about 35 parameters which can be trended. I mean, it can be mapped. The trends can be mapped. So we'll not deal with that. And what I suggest is, as a strategizing tool, use 5 or 6 important trends. And trends are mapped, 4th step or 6th step, which is a knowledge derived from that patent. I can now understand in a particular trend, like controllability. There are 6 phases, right? 6 positions. Now, current system is in the 3rd position. I have a knowledge up to the 6th position. Can I move from 3rd position to the 6th position or the 4th position? Is what strategizing innovation is all about. Okay. So basically, I will just rush through some, thing like, system with the one state, system, with the discrete different states, system continuously variable. It's one of the trends of increasing dynamism, flexibility. Okay. So we have, like starting from a monolith, the folded scale, folded differently. Ultimately, we have a laser, a measurement, right? I can have a measurement. So this is a physical arrangement, right? It's been replaced. And this is a very interesting thing, I always say, the C.V. Raman was using a pointer, very monolithic, right? Single piece. Then what happened? Foldable, I'm skipping. So it's a collapsible, right? You have a pen, telescopic pointer. This has now been replaced by laser, which itself is not there. I hope, this is the proof that technology predictions, trends can be used for innovation. Okay. So I wanted to give you some example, dynamic, flexible, dynamic design of jewelry. A set of beam, I can create any design as I want and wear. Beautiful system of jewelry. It uses magnetic field and stainless steel, which is magnetic. So I'm just showing you something. Can the shoe be dynamic? It can be different colors, different shoe. Heel heights. They are all sold in the market, gentlemen. Okay. So let's take automobile axle. So suspension is those single independent suspensions, interconnected suspensions, active suspensions, and active suspension forward sensing. The future vehicles, at least for defense, they could travel anywhere with this kind of suspensions. Okay, this is the predicted trend. Okay, so I come back to the monolithic, solid, active. Basically, if you see the brick, now we have seen this brick, solid, with depressions, multiple depressions. Now hollow brick, I hope most of you have seen, right? Only one trend is left here. That hollowness, the pores there, you must fill something with that. Cavity has to be filled with some active element. So there were good, lot of possibilities are there.
Because Achutha, Holcim has come up with a cement which will make that type of porous brick from which water can go down.
So actually, that's much better. We could do, if I'm selling this brick in Nagpur, I will have a better insulator, right? I can do that. If I'm selling this brick in Bombay, I can prevent, the plastering and see that water does not percolate. This is all the possibility, right? But actually, one innovation has happened. If you see that, it is filled with the elements which will generate power. You can, so this is a very interesting things, okay? So, okay, so now, I'm just showing you a piece, like, market evolutions. From commodity selling to product selling to service selling, experience economy, transformation economy. That's predicted. We will have the whole new systems, okay? So, purchase behaviors. performance to reliability to convenience to value. So every trend changing has benefit to the society. Okay. Now, reducing number of energy conversions in a system, very, very important. Like 3 energy conversions to single energy conversion, 0 energy conversion. Can we have this? System becomes very ideal. Okay. So degrees of freedom, right? When I, 71, I completed my design, right? We could not have thought of the shapes that you can think today because production capacity did not have the 6 degrees of freedom that you have today. You can create anything, any shape, you can produce it. Unfortunately, X and Y only the contour of the tool will give the profile. Even to give a radius, TV, if I have to have a radius, large radius on the plastic box, would have been very difficult. So degrees of freedom, right? We are today dealing with 6 degrees of freedom. That's why, you have such a controllability and such a dynamism in the systems. So, it's a very interesting, dynamization that is, field-based systems. My gentlemen, you have to use of fields. Okay, I'll just give you some examples. Laser cars may be started using lasers in future. There's actually General Electric doing already experiments. So this is the power of, because it is controllable, highly effective, most efficient fields. So you go to cooking, solid, liquid, gas, and comes ultimately to the fields. All right. So what is the latest in the field is your induction heating, which has been known to the mankind for 100 years. Industry was this, they never brought this to the house. And this is where, using this. Like, for example, Crompton Greaves is producing a storage heater. If he's today using an electric heater, actually must go to induction heater. There's a next level, the future water heaters will be. I'm just telling you how you do that is what, you are missing. So if you go to the, like your microwave is input in that, but induction heating is the most beautiful thing of tomorrow. But, based on this, when I was in NID, we did a study that there may not be any kitchen at all. Because induction heating allows us to create cooking even in a drawing room or a dining room or whatever it is. That's the kind of visualization we can have. So let's go to cutting. Now we are full in the field. What is the field? Laser cutting, right? Most important, most efficient. Okay, we are moving the same trends. Just to demonstrate you that what I talk is, we have got, proofs. Okay, that's what I'm doing. Use of laser, fields. Like, you've got this, identity packs. You have to actually use a pin, pick the hole, and, you could use substitute with a magnet. Actually, this is actually my son's badge in ULCA when he was doing, in the MBA. So it's magnet actually. Field. Okay. And so this again, going from rigid to, probably electrical field. We'll have electrical steering if you tomorrow. We have moved from hydraulic system to electronic system, etc. It will have. So this is the power of, all this knowledge is available to me. If I have the ability, like I can invest in new technologies, actually I can jump from here to here. This is depending upon how much the company is willing to do that. Okay. So I just thought, 3 days back, IIT Bombay discovers a new magnetized catalyst to increase hydrogen production. Magnetized, they use magnetic force to improve and reduce the cost by 1/3 actually. It is, 3 times better, faster. So this is the power of using fields. Remember, gentlemen, what fields can I use, how we can use, because we have different types of fields. The fields are static or dynamic, so there are, further knowledge. Again, if you go over to this, you'll again follow the same thing. What is the field here? We have the electric power. Okay. So this is actually, I think, Benz, futuristic car, which is dynamic. Dynamic means what? The motor is not, replacing the IC engine like the current electric cars are there. When you replace an IC engine with the electric motor, you're actually carrying forward all the ineffectiveness, deficiencies of the mechanical transmission system, which I do not know why, these electrical manufacturers are not thinking about. So this is a hub motor, independently controlled. That means efficient from, the lowest RPM to the highest RPM, intelligent feedback. So use of fields, energy conversions are reduced. So this is how, this is supposed to be launched actually by 2020. I do not know what happened. Okay. So, somebody has thought and patented even a magnetic levitated car also. So, example of use of fields. Electrical presses, earlier, we are all taught in engineering that mechanical and hydraulic systems are most efficient, right? All that knowledge is useless. So, today everything is becoming electrical or, using other fields. Okay. I mean, just some, use of magnetic field. Again, this power, your all electronic, products, wires of the mobile, all these things, using magnet actually to use them, arrange them. Beautiful. I think, one of the, this thing, videos of Bauhaus, I mean, he says that, I need to, probably can I have a levitation chair? Actually, I remember one of the Bauhaus videos. And they are all actually conceptualized and they are being proved. Levitating, chairs. So let us just map this. So I'm coming to the end. I hope you will be seeing. It was a solid brick, right? So the mobile as a solid piece. So basically, I can map solid object divided into two segments based on the trends, and ultimately flexible objects. I can have probably wear around my wrist. This is how the prediction happens. So actually it goes because the display is very small. It's a contradiction, right? Now I need to have a larger display. That's why I have a foldable mic. I do have a foldable device here. Okay. So I have a large display. So contradiction resolution leads into the next technology evolution. And so this can be rotated as you want. So this can be multiple rotations. These are all conceptual things. They never actually put into the market, but they are all patented. So actually can we have a flexible screen itself? So, which actually, dynamic, right? One of the trends says that you should have flexible screens. So, I mean, this is the Nokia's experiment on flexible screen, that variable mobile. So, this is a very interesting, flexible screen. Like, Samsung, all of them are coming with a foldable phone, right? Which means the screen is flexible. So, MIT have created a display screen that can be printed on rolls of plastic sheet. The way newspapers are printed, the first practical application will be to provide arbitrary detailed maps and other data storage that soldiers in the field can have. So, this is a requirement of the field. Like, if American soldier is there in Afghan and, he has got a laptop and it is, he is caught by the, the enemies, what happens? They can decipher all the knowledge, right? Now here what happens is he does not have anything. Actually, the information is sent by satellites. So this is the kind of thing. Moment this becomes common, we will have this, foldable mobiles, very, everlasting, etc. So see you can actually see a lot of development taking place in going towards ideality. What can be the future mobile? To me, will it be a mobile or a camera? Now today, is it a mobile or a camera, gentlemen? Huh? I do not know. Mobile, nobody's talking, right? More and more camera, they are talking, right? So there's a question. In my opinion, it will not be any more mobile. The entire function of mobile is a very small function of a laptop. Consider a laptop. So a mobile will be a part of a super system, that is means, laptop. So the laptop has to shrink to the level of mobile or a foldable system. Okay, they produce a pad, which are huge, not comfortable because no foldability. So a mini laptop, foldable screen with most of the functions of the laptop included, because it becomes a companion, which is what I predicted, when I was in NID. And so you have to have more than just the mobile functions. Probably it will have, half of the office functions available to you. You can work from anywhere, etc., etc. With many other apps to check, maintain. Probably most of the medical health requirements will be built into that. So you need to have a very different system. But it can be still portable, put in your pocket and carry. So that is what, according to the TRIZ, the prediction, it tells what will be the future mobile. A personal companion, I call it as a personal companion, in which the functions of the mobile will be the basic function by default, with many other essential new functions of higher order, priority for the day-to-day life is included. That's how we can design. A keyboard is very fixed, right? So these are actually already sold in USA. So keyboard is not, the characters are not printed. They are all created by LED. So I can create a keyboard which can be sold across to any language. So, this is a very beautiful system where, there is universal keyboard. Okay, we can create the characters And so this is already sold, and then I will show you the product. This was actually, Apple also has filed a patent about 3 years back for those kind of keyboards will be very dynamic. Okay. So basically, how do I strategize? Assess the evolutionary state of the current system in dimensions of relevance as required. So there are 38 trends we can map, but I don't have to do that. Maybe 6 trends I can map, 6 parameters I can map. So you create actually maybe human involvement, how much is the involvement of human being. Controllability, you can also see that. Probably dynamization, flexibility of structure, flexibility of operating state and flexibility of form. All those can be the parameter which need to be mapped. And then energy path, absolutely, is very important aspect. So like that, we can choose most important parameters which affect my innovation, strength. And then we will see, create a, radar chart. So we have, chosen fixed matter. So today, these are the knowledge available. So in particular, this parameter, I am at this stage 1. So I can choose to, go from 1 to 3 or 4 or 5, depending upon my capability and the need of the society. So every parameter, if I am already here, I don't have to do anything. Okay. So this is how I propose that, innovation can be strategized by, because all these knowledges are available, gentlemen. When I say this, the trends, they need not be uniform, gentlemen, though it is shown here as uniform. Some of the trends may have only 4 stages. Some of them may have 6 stages. So that is just a graphical way of showing this. So this is how, the strategization of innovation can happen, and see, we can say, visualize the product of the future. Okay, this is how it is done. Okay. So the outside parameter, which anyway I have already explained, right? Now let me come back to how, TRIZ will help us to, as a design thinking process. So we have an empathize process and define phase, which I hope most of you are familiar. So basically, this is a research paper which I have taken. So actually, if I can visualize an ideal system using the system operator and other tools that we have, it will help us to redefine the problem in a much, much different way. And, I have very different tools like resources, physical contradictions, technical contradictions, evolution trends, all of them become a part of my definition of the new problem that I want to do. And I have, many, resources available to ideate much better than the conventional, approach that we do in design thinking. And then we have this thing. So this is how I say that how the tools of the TRIZ can be embedded. And, when you want to become a, design, embedded organization, probably this has to be part of the system. Okay. So generally, this is again, another research finding. So in the convention, problem identification, problem formulation, search for ideas and concepts. Actually, it is the opinion that TRIZ actually helps us a lot in developing very new concepts, much easily, very systematically, and that's why a higher level of innovation is possible. Okay, so this is the, the interpretation, how TRIZ can be embedded into other innovation processes. So I think this is my last slide. Yeah, so, yeah. Now, I do not know whether I occupied 1 hour or is there a time or people are sleeping. Yeah, I think I exceeded my time by about 10 minutes. I'm so sorry about it. Yeah, now if interested, I'm open. So for any questions or any comments or any observation that you want to make. First of all, I think Chakravarti, you were there. I'm very thankful to you. I do not know.
Not at all. Why thankful? Like I learned so, I was very interesting, very nice to go through, and it is fabulous.
Yeah, you must remember that I could identify your voice.
Yeah, thanks.
So I met you very, very, many less times.
Yeah. So good. In fact, I like to share a lot of what I'm also doing this, so we can share notes and invite you for some of my classes. That will be wonderful. Yeah.
Actually, Munshi only put me. There is a comment.
Classification. Yeah, very well done. Yeah.
See, one of the thing I must tell you is actually, I was 3 or 4 years back. There is a consultant who is consultant to L&T in Bombay, technology consultant. So they have a technology enclave. 3 days program they do because they have about 200 units and wonderful work is done. And IIT professor actually wanted to. I mean, it seems they got a maximum demand that introduction to TRIZ was to be done. Okay. So then, Munshi contacted me. I said, Rao, can you, take this responsibility? Then I myself told Munshi that Dr. Apte is there. Why are you not, recommending Dr. Apte? he said, no, are you willing to come? I mean, I said, okay, I can. And so then, I continued to do a lot of programs for them, actually, how to introduce thing. Actually, a TRIZ expert looks at that tools of TRIZ in a very different way. I mean, my, understanding is that when the designer actually absorbs the TRIZ, we look
very
at their
different,
knowledge in a very, very different way. I mean, this is what has been, understood by me and learned by me. And so
Sure.
it has actually given us a lot of opportunity. Dr. Apte was actually a consultant to one of the airports, for TRIZ applications. So they were not probably very happy. Then somehow they then approached to us, can you do that? So I have to, then when we actually did that, program for them. So the beautiful, thing is that, the CEO of the airport, he said, how do I travel in a bus? I just, come to the bus station, I get into the bus and I go off, right? So he says, I want the airport travel to be like that. I mean, there's, the environment, he said, beautiful, the scoping was done very beautifully. So don't assume anything. I mean, whether it takes 10 years, 20 years, 30 years, 30 years, you don't worry about it. But come out with concepts, which are actually futuristic.
Right.
I mean, so that's what the power of TRIZ can,
Right.
can actually do it.
Sunil here.
I have a question.
Yeah. I will post the slide. Is that okay? I think.
Stop the sharing. Yeah, stop the sharing.
Yeah, stop sharing, right?
Hello. Am I
Yeah,
audible?
Yeah,
Yeah,
Ganesh.
yeah.
Sorry. I have a question. I think you have wonderful examples of innovation, but I would like to know if there is any example of innovation which eliminated the products entirely without creating new products and made the life better for human beings. All examples create some of the other kind of product, but using trees, is there any example which eliminated the products altogether and still made the life happy for human beings?
Yeah, I just showed you one example of laser pointer. I mean, you don't have to use a laser pointer now, so it is eliminated, right? So, I mean, there could be, if you give me time, I can think of so many examples where, it has contributed to the quality of life. Some noise, I don't know whether from my end or which system is.
Ganesh, I think your system is giving some noise. So you could just go on mute when you're not speaking.
Thank you.
Or somebody's house or somewhere, I don't know. Some mixie is running.
Sure. I have a
Yeah,
question.
very, very nice. Very quite.
Ganesh, if you're done, can I ask my question?
Yeah, please go ahead.
Okay. Yeah, this is Sunil here. Coincidentally, I am taking design, technology, and innovation at IIT Bombay for BDES students this time. I think so. This
I do not know. I don't know. One of the IDCN actually has undergone a MDes program or master's program in Russia. I do not know who he is because I just happen to know about it.
Okay. So I'm just taking it as a faculty, visiting faculty right now, adjunct faculty right now. So this came as a very convenient time. So my question is, TRIZ seems to be very organized and methodical in the way innovation is happening.
Yes.
I was just wondering, which made me wonder, can we automate the entire process of innovation itself?
To some extent, you may do that because in intelligence thinking, like it says, segment. I mean, one of the inventive principles it says, segment means divide into so many parts, right?
Mm-hmm.
So how do we do that? Automation, whether it has been divided in, like 6 parts or 4 parts or 5 parts.
Mm-hmm.
That kind of intelligence is not probably at the moment we are still not capable of doing it.
See, what it gave me was an idea. I mean, this is just a brainstorming thing. So,
Yeah.
What's running in my mind is an app for designers or for app for anybody to innovate.
No, actually, thesis can be learned only by seeing the previous examples. So, if you buy it, Tech Optimizer is one of the software available. There are many Inventa, I think, some USA there's one there. Creax is another software that you are getting. So, actually, they published examples across the globe.
Okay.
So, from different dimensions. So, the TRIZ can be understood only by looking into these examples. So, the descriptive word, text descriptions are not capable of doing it. So, learning TRIZ is a bit difficult. It requires a lot of time, constant seeing the examples. Like, what do you mean by segmentation? how do I use this and develop the concept requires
Okay.
exposure to the previous examples. So when actually I was MS Ramaya where we did this, so whether we should buy a software or not software, one of the question that happened was that software will pick up any innovation that you are doing and it will also share with the world. So that was the biggest danger I found. So because you are already connected to it, your software, the tech optimizer sitting in your system, will also pick up the work that you are doing in terms of innovation, new innovations, and it will also share with the world. That's the observation that we have found. So that is one. That's why then we said no, we will not buy the software. Actually. So this software will take you and help you to find solutions, but it will not generate solution by itself.
Got it, sir. Yeah. Thank you.
Yeah. So actually, Tattva, I mean, there's a innovation enabler. Actually, there's one student who has a student. I do this program in, ISC as a proficiency course, evenings. So he became my student. He's an MBA and then he was a consultant working in, Boston Consulting, etc. So he was my student and within next 1 year, actually he wrote a software where entire innovation can be managed. Anybody can have, so he brought a lot of systems. You can probably just explore. I mean, Tattva is this thing. So innovation enabler, enabler is a company. So if you request, I can send you something. So there, he put all my, teachings as a software kind of thing, which people can actually use and monitor and, measure, and everybody can use the tools that are there. Like, all these tools are available as what you mean by, technical contradiction, how to resolve. They are available as, the approaches.
Thank you, sir. Thank you.
Yeah. So if no other this thing, I think we'll let. Yeah, so 21, I think it's okay. 10, 20.
Yeah, no, I think it was a roller coaster of a ride through the presentation. A lot of information, a lot of knowledge sharing. So I think it will take us time to even absorb this. I mean, to me, it was a very new concept.
See, it is not easy to learn. I want to caution because when I introduced as a semester subject, it was tough. But a lot of my students landed in patents actually. I mean, the first batch itself. So because they could, I was insisting on them then on using these knowledges. Even develop actually like Tata Elxsi. I think Sham is there probably. Dispensing solids, dispensing liquids, dispensing creams and all. So many of my students landed in the first, as a project, landed into patent systems. And fortunately, his clients were all, non-Indian companies, British company. I remember a British company gave him the right that will record that you are the innovator and then you give the right to us.
I hope this is only the beginning and we are able to call you for more sessions. So hopefully soon again.
Yeah, I mean, once you learn, you will be really enjoy using it. I mean, that's my experience. So it requires a lot of effort because imagine it's not just the only one tool. I mean, there's a combination of tools that we can always use. I always believe as a designer that you will learn many tools from many approaches like value engineering, Six Sigma, etc. And bring that to the design process. You need not be confined by the tools that are taught to you here. You always require new methods and tools, and then you become a designer. So this is my approach. Yeah, I'm very happy that Hari is there. Oh, what great that Hari was there. Hari Nair. They are my juniors at that time, right? So very nice to this thing. Yeah.
So if there are no further questions, we can close the session. And thank you, Achutha ji, for this very informative session.
Yeah, it's my pleasure. Honest willing to share whatever I could.
Good night, Professor. Good night.
Professor Rao.
Okay.
So now you can change your mobile. Your mobile number is anyway there. Yeah. Okay. Bye. Yeah.
Bye.
Bye.
Yeah.
Okay. Thank you.
Thank you.
Bye.
Thanks, Namesh, for doing this.
Good night.
Thanks, guys.
Good night.
Bye.
Thanks.